Okay? That's what I want to explain to you today. Now, everything, a jar of water, sitting here. Jar of water I've got. I'm going to use this in a sec. Actually, I'm not going to use it as a demo, but I'm going to use it for an example. I got a jar of water sitting here. Back here. And I put the lid on and it's airtight. Just hanging out there. Ever notice that sometimes, some things when you open them up, you hear like a fizz? Okay? It's like a pressure that built up just with that jar. Obviously, sodas do this. But I'm not just talking about carbonated things. Other things do. For example, I'm sure you've all opened up in a hot summer day. You go out you're going to mow the lawn. And you open up your gas canister to do that. And you'll hear this release of pressure that's built up. Because gasoline is evaporating. It's trying to evaporate, but it was in a sealed container. So it built up pressure. Those water molecules that were in this jar, okay? Here's my lid on top. It's got some evaporation and some condensation, and it formed an equilibrium. Now, so let's say I've got this jar filled with water. You've all bought bottles of water that are sealed. They don't make a little fizzing sound. They don't have that high of a vapor pressure. They don't have much pressure above them. But other things, like I said, gasoline, they're evaporating more. Okay? They aren't going to be held together as tightly. They both are at equilibrium, but if this is, say, gasoline, and this was water, don't you all agree that there's probably more evaporation in gasoline? You can tell by the pressure that's built up. Now, I want to talk about what causes that vapor pressure, and based on how these guys are held together, what makes up those molecules, what makes up those compounds. And that's what I want to talk about right now. It's just one board, won't take me very long, but there are going to be questions on this worksheet on vapor pressure. Okay? It is, as I said, the pressure exerted by the vapor phase, basically, of a substance at equilibrium, based on how much it wants to evaporate. And this is going to depend on two things. I used to have an animation, but it doesn't work anymore. It's blocked. The site's blocked. Hold on. I brought some little bit of notes in here. It actually depends on two things. For some reason, I don't know why I forgot this. It depends on the temperature and the identity of the substance.
Did you write that?
I wouldn't be writing it on the board if you didn't, Emily. And whenever I do that, Emily, what do I say right before I write them? You don't know? I'll give you $1 million if you tell me.
Don't copy this down.
Yeah, wow. It's amazing how much you know. Here's your $1 million. So it depends on the temperature and identity of the substance. Obviously, I can raise the vapor pressure by raising the temperature. That's what happens when your gasoline sits in the garage in a hot summer day. But the identity is a big deal too, and that's what I want to talk about here. Guys that have high, I have to erase this now, I hope you all have a copy. All right, guys that have high vapor pressures, I want you to tell me some stuff about them. I want you to think and use common sense. These are the kind of questions you're not going to have to memorize, people. These are the kind of questions you're going to have to just be able to understand. And by the way, the first worksheet I graded already. And there were some, the grades were not fantastic. They weren't horrible, but they were not fantastic. They weren't all 25s out of 25, which is what that one was worth. Okay, so this is the kind of stuff I said before. Even if you study it, you can't memorize it. You have to understand it. Let's practice that with this example. Without me giving you the notes, I bet you could answer the questions I might ask you on a test about this. Let's say I asked you, would you expect a guy with a high vapor pressure, first of all, to be evaporating a lot or a little? A lot. Secondly, would you expect that he's going to be held together with strong intermolecular forces or weak ones? Right. Why? Because he's turning into a vapor very easily. He's not being held together very well. Good. And Finally, would you expect this guy who has weak intermolecular forces and is evaporating very readily, would you expect this guy to have a high or a low boiling point? Exactly. Now, how do people? I know that one was because it was step by step by step. I noticed a lot of other people were kind of like the wheels were still turning before people started yelling out an answer. They probably don't know why. All right. Well, think about it. If it's not held together very well, and it's already evaporating pretty easily, it's not going to be hard to boil it. It'll be pretty easy to boil it and break them apart, right? That's why he'll have a low boiling point, because it was easy to boil him. See, it's common sense. It's using, deductive reasoning. You're not just memorizing, like some of you are wont to do. And I honestly, God, it's exactly what I predicted. I don't want to use any names when I'm not just goofing around. But it's exactly what I was thinking in my mind. In the papers I just corrected, I corrected both papers for the other class. And there are people in the other class, and there are people in this class, who are great memorizers. You can tell they're good memorizers. They're the kind of people who are very conscientious. They study for every test. Very good memorizers, but not necessarily the best at understanding things. Sure enough, their grades on those two worksheets were not very high. Because it doesn't matter. They have the notes in front of them. You'll have the notes in front of you in 2 minutes when I'm done giving these notes. You'll have them right in front of you, but if you can't apply it to answer a scenario question about boiling an egg on top of a mountain or whatever, if you can't apply it to the vapor pressure, you're going to have a hard time getting the right answers, even though you're really good at memorizing. It's really smart. All right, so that's the high vapor pressure guys. Examples of that would be stuff like gasoline, alcohol, perfume, things that readily evaporate. Obviously, if I go to low, I don't have to spend as much time on this. Guys with low vapor pressure, what are you going to expect? The exact opposite, right? If they have a low vapor pressure, they're not evaporating very readily, right? They're going to have very strong intermolecular forces because of that. I mean, not because of that. Because they have strong intermolecular forces, they're not evaporating very readily. And what would you predict for their boiling point? If he doesn't want to evaporate, if he's held together really tight, it's going to be really hard to boil him. He'll have a very high boiling point. Can you think of things like that? Water is a great example. Water should not have the boiling point it has if it weren't for what kind of bonds hold water together? Hydrogen bonds, exactly. So water, you ever spill motor oil on the garage floor? You spill gasoline on the garage floor, you come back 2 minutes later, it's gone. It's evaporated. You spill motor oil on the garage floor, you come back 2 weeks later, it's still there. That's staying in motor oil. Because it's held together tighter, it's thicker, it's heavier. It's got stronger intermolecular forces. So does water, have very strong. I know you say, well, water evaporates pretty quickly, but not considering how heavy he actually is. Considering it's made of just 2 H's and an O, his boiling point should be like 200 degrees lower than what it is. If you remember that chart we did, remember that when we did the graphs? We did 4 different graphs of hydrogen bonded group elements, looking them up, and we just graphed them, and we noticed that oddballs in every case were the guys with the hydrogen bonding. They're held together tighter. All right, good enough. Now, it's another example of this. Let's apply it to what we were just talking about a little while ago. Guys who evaporate readily. You ever get alcohol? Everybody's had the swab, an alcohol swab before you're shooting up, right? Hey, it's perfect, all right? So, no, before you've had blood or whatever, and you've had an alcohol swab, how does it feel when they put that on? It feels cold. Why does it feel cold? Because unlike water, it evaporates faster than water. Alcohol always feels colder because it's evaporating off so quickly. As a matter of fact, there's those sprays that numb, like sports injuries. Anybody have one of those? Why do they work? Because they're evaporating readily off your skin, and they will actually get so cold they'll numb your skin. Okay, so that's actually another good example. Okay, let's give you those worksheets.